Hello everyone and welcome back to MacTech 40, and today we will see one question based on epicyclic gear train. Okay, and this question is asked in GATE previous year question. Okay, and we will solve today by table method. Okay, and because this is the very well known and very easy method as far as our competitive exam concern. Okay, and your university exam concept. Okay, so let us see. So the question is, an epicyclic gear train as shown in the diagram, the gear 2, that means this, the centermost, it has 20 teeth external gear, and the planet gear, that means this number 3, it has 40 teeth external gear. Ring number 5, that is this bigger circle, that is 100 teeth internal gear. Here internal gear, the ring number 5 is fixed, as here you can see, that means its rotation is 0, rotation 0. And gear 2, that means this centermost gear is rotating at 60 rpm counterclockwise. So we have to find this arm which is connected to sun and planet gear. We have to find its speed and its direction also. So first of all, let me clear the sign convention. If gear is rotating in clockwise direction, then it is taken as a positive, and if gear is rotating in counterclockwise direction, then it is taken as a negative. Okay, so this is an epicyclic gear train example, and this I have told you the sign convention. And one thing, suppose if two gears are meshed externally, so their sense of rotation will be opposite. Okay, suppose for example gear 2 is rotating counterclockwise in the question given, so this gear 3, the planet gear, will rotate in clockwise direction. But if two gears are meshing internally like this in our case 3 and 5, so the sense of rotation of the both the gears will be same. Suppose if this rotating in clockwise, then this bigger internal gear will also rotate the same direction. Okay, so with this sign conventional, let us start. So first I will make a table, and this is useful in each and every epicyclic gear numerical. So we have to divide the number of parts as much as number of the gears. Okay, here as like this. Okay, so this is, and here we will write as a condition, which condition we are using, like condition. Here first thing is what? Arm. Always write first arm, then here there are number of gears, so which gear we have to write first, or which gear we have to write the next. So always my approach is what? Always go from center to outward. Always start from center and then go outward. So as we start from the center, we have gear number 2. So here write down gear number 2, then gear number 3, then gear number 5. Okay, so first condition is that we are assuming that gear 2 is rotating is one rotation in counterclockwise direction. This is our assumption, and we are not considering about arm, only one rotation, so it is -1. So what is the corresponding speed of the gear 3 from the gear ratio? Minus T2 by T3. Here I am denoting T as a teeth of the gear, corresponding gear. T2, that means teeth of the gear 2. T3 is the gear of the T3. Okay, because these are meshing with each other, but here the sign will be plus. Why? Because gear 2 is rotating counterclockwise and it is meshing externally with gear 3, as you can see in the figure. So it is positive. Now gear 3 and gear 5 are meshing with each other, and it is in same internally, so the direction will be also positive. Okay, So here T2 is meshing with T3 and T3 is meshing with T5. Okay, so T3 will get cancelled. Only we have that T2 by T5. I'm erasing it and again writing this. So positive T2 by T5 and 1 is multiplied by 1. Now we have assumed that it is rotating x rpm, only gear 2's rotation. Though if we measure with the rotameter, then it is minus x rpm, and it is y, sorry, minus, it is minus minus plus x times T2 by T3. Here plus x times T2 by T5. Okay, now I am adding speed of arm speed y. I am taking speed of arm y, add in all this. Now we have arm speed y, here y minus x, add this 2 row. Okay, y plus x times T2 by T3, here y plus x times T2 by T5. Okay, got it. So here these are the two, and this is the equation, this equation what we get here. These are the equation of total rotation, that is the rotation that is given in the question. So what in the question is given? The gear 2 is rotating 60 rpm counterclockwise. Okay, so we will write the gear 2, that is y minus x, that is 60 rpm. Okay, and the other gear y plus x times T2 by T5 is equal to fixed gear. It is not rotating, but T2 is the teeth of the second gear, that is 20 teeth, and it is gear 5 teeth, is the teeth of the gear 5 is 100. So y plus x time 20 by 100 is equal to 0, or you can say that y plus x by 5 is equal to 0, or you can say that y is equal to minus x by 5, or you can say that x is equal to minus 5y. Now put this value in this equation. Y, x is equal to minus 5y, so minus minus plus 5y is equal to, it is minus 60 because it is in counterclockwise, minus 60. So total 6y is equal to minus 60. So y is equal to minus 10, and this is our answer, minus 10 rpm, the speed of arm. And this minus sign indicate that the arm is rotating with 10 rpm angular velocity in counterclockwise direction. So as you can see in the option A is your correct answer. So this is the method to solve any epicyclic gear train numerical. Okay, hope you guys clear this. If you have still any doubt, ask in the comment section. We will solve your query in upcoming video. Till then, keep studying, stay focused, and stay safe.